Before we start today's lesson, you will need a pen, some paper or an exercise book, and unless you're watching this video on your mobile phone, then please turn off your mobile phone and remove all distractions. Hello and welcome to today's lesson on titrations. This forms part of the triple only content and should only be attempted by students undertaking the chemistry only specification. My name is Mrs Kershaw and I'm one of the science directors with Outward Grange Academies Trust. Our challenge today is going to be to describe how to safely carry out a titration. Our aspire is to explain the steps that you would take to improve the accuracy of your experiment. But first of all, let's do a quick recap on what we've done in previous lessons. So there's 4 quick questions and an extension. 3 minutes, off you go. That's great then. How much could you remember? So first of all acids contain H+ ions. The difference between concentrated acid and a dilute acid is that concentrated acids have more acid molecules present per unit volume. Concentration is measured in moles per decimeter cubed. And the word equation and balanced symbol equation for the reaction between sodium hydroxide and hydrochloric acid is sodium hydroxide plus hydrochloric acid produces sodium chloride plus water. There's the symbol equation, and for those of you who attempted the extension, then the neutralization equation showing only the ions that are used in neutralization is OH- plus H+ forming H2O. And just a reminder that in this equation, sodium chloride is a neutral soluble salt. So what is a titration? A titration is basically a neutralization reaction between an acid and an alkali. We use these to work out the concentration of one substance that we don't know using a substance with a concentration that we do know. To do this, we use special equipment that is very accurate. We use a burette and a pipette. We will also use an indicator which will tell us exactly when neutralization has happened. So examples of indicators then. We've seen previously that indicators are substances that change colour depending on the pH of the substance. And previously you will have looked at universal indicator that goes 14 different colours from 0 up to pH 14. The problem with universal indicator is that it has 15 different colours. Some of these colours are different shades of one colour, and it can be very difficult to tell when it's exactly pH 7. As you can see there are at least 3 shades of green, so knowing which was the green for pH 7 is quite difficult. So for the titration we're going to look at today, we're going to use an indicator called phenolphthalein. It's a better indicator because it is only pink or colourless, and at exactly pH 7 it becomes colourless, so it's easy to see when the solution has become neutral. This is what we call the end point, so the point at which the solution becomes neutral and we see the indicator change colour is the end point. We are going to use phenolphthalein as the indicator for our practical, and that is the one that you need in the required practical. However, one of the ways in which they may ask you to apply your knowledge of indicators is to give you a different indicator. Should this be the case, they would tell you in the exam question the colour changes, and you would need to read the information in the question and see what colours the indicator was in acid, neutral and alkali, and then apply that to the question. So why do we use titration reactions? Well, if the concentration of one of the reactants is known, the results of the titration can be used to calculate the concentration of the other reactant. And in our next lesson, we will be looking at how we use this data to determine concentrations using the formula concentration equals moles divided by volume. This is an equation that you will need to learn, but more of that next lesson. In this lesson, we are going to look at how we would use the equipment shown to perform this titration and get a set of results. So I mentioned before we use 2 pieces of equipment, a pipette and a burette, to accurately measure exact volumes. The reason we use different ones is that a pipette will measure an exact fixed volume, so that's the same amount every time, whereas a burette can be used to measure an exact variable volume, so that is a volume that may change each time. The definition of these two things is a commonly asked question. Okay, I'm now going to give you 3 minutes to record the information I've just told you by answering the 3 questions shown on the screen. So how did you get on then? What is a titration reaction? It is a neutralization reaction. Why do we carry out a titration? We do this if the concentration of one of the reactants is known. The results of the titration can be used to find the concentration of the other reactants. And why is the acid measured using a burette and the alkali with a pipette? That is because the burette gives an exact but variable volume, whereas the pipette measures an exact fixed volume. If you need to pause the video at this point and correct your answers, then please do so. Now I'm going to show you a video demonstrating how to carry out a titration reaction.
Hello, my name is Mrs. Kershaw and today we're going to look at the required practical for neutralisation. This is a chemistry only practical and appears in Unit 4. For this experiment we are going to use a burette, a pipette filler. We are going to use some white paper, or you might have a white tile. We are going to have an acid, an alkali and an indicator. Right, so first of all I'm going to fill the burette with acid. We are going to use sulfuric acid for this practical and I am going to use a funnel. Now this is quite high, so one of the things that students don't realise is actually you can just move this round and move it to a level that's more accessible. Before I start putting the acid in, I need to make sure that my tap is closed and that it's crossways, otherwise the acid will just come out. I'm going to put my funnel in the top and I'm going to add some sulfuric acid. Okay, I've slightly gone over the zero because one of the things I need to do is to run a little bit of the acid through so that we fill this at the bottom. This is called the jet space and it is accounted for in this measurement. So I'm just going to run that through a little bit. Right, and that is to zero. You'll notice that I'm looking at eye level and I'm also looking to the bottom of the meniscus. So I've now got my acid in my burette. I'm now going to put my alkali in a conical flask and I'm going to use a pipette for this, and the reason we use a pipette is because it's very accurate, but we're also using a fixed amount each time. So we use the burette because that may vary each time for the acid, but for the alkali, which is a fixed amount each time, we use a pipette. And again, I need to get this to eye level so that the bottom of the meniscus is just on the line of the pipette. And then I'll add that to my flask. Don't push that down. There's something on the side, a little lever on the side that will allow you to empty the pipette. When you get to the end, you're going to touch the last drop off the end of the pipette. Okay. Right, so I've now got my acid and my alkali, and it's a neutralisation reaction. You will notice that both of these liquids are colourless, so I need some way of knowing when I've reached neutral. And what I do is I add an indicator. This time I am going to use something called phenolphthalein. I'm just going to add a couple of drops to this, and you'll see in alkali, phenolphthalein is this beautiful pink colour. Once we get to neutralisation, it's no longer an alkali, so we've got to pH 7, this will go colourless. Now, when you're doing a titration, usually you would do the first one, do it quite roughly, and use that as your indicator. measurement. After that, you then do them very accurate, where you will do it dropwise towards the end. I've already done the rough one, so I know that it's about 23 centimetres cubed. So this time I'm going to add it and quite quickly, got my piece of paper, quite quickly until I get close to that 23 centimetres cubed. So I'm quite close to 20 now, so at this point I'm going to start adding it a much slower and add it drop by drop, so I get a very accurate measurement of exactly how much sodium acid I've added to the sodium hydroxide. Remembering to keep swirling. And you can see at that point we have just gone colourless. And my result this time, again looking at eye level and reading to the bottom of the meniscus, is 22.8 centimetres cubed. I'd then repeat this until I got two concordant results. Concordant results are results that are within 0.1 centimetres cubed of each other.
Okay then, so just a couple of points. We need to make sure that we read the values correctly on burettes and pipettes. And the way that we do this is we use something called the meniscus. This causes a visible curve on the surface of the liquid. And to get the true value, you must read it at eye level and you must read to the bottom of the meniscus. Okay, so to increase the accuracy of your titration and spot any anomalous results, you will need to take several consistent readings. As we've seen, the first titration is just a rough titration to give us an approximate value of where our endpoint might be. We then need to repeat the whole thing, being very careful near the endpoint when we add the acid drop by drop. We repeat this until we get concordant results. These are results that are within 0.1 centimetres cubed of each other. Finally, once you've done this, you will calculate a mean of your results and you will remove any anomalous results. When you are asked to write a method for a practical, you must always include a risk assessment. We can see here that if we lower the burette to eye level before pouring the acid, that will make it safer rather than stretching above ourselves. And secondly, we should wear goggles because acids and alkalis are corrosive. Please do not write about tucking chairs under and bags and coats out of the way and ties tucked in and hair tied back, because these rarely, if ever, gain any marks. Okay, 3 more questions for you then. How do we determine when the end point of a titration has been reached? Can you give me 2 reasons why you repeat a titration until you have concordant results? And why would you wear goggles? 3 minutes. Great, so we determine the end point of a titration because the indicator will change colour. Two reasons why we repeat the titration is to increase the accuracy of your results, to spot any anomalous results, and to calculate a mean. And we must wear goggles because acids and alkalis are corrosive. As this is one of the triple only required practicals, this frequently appears as an exam question and you need to be able to write a method. So we are now going to look again at the method step by step, and afterwards you'll be given the opportunity to write a method. We are now going to look stepwise at how we would perform a titration. First of all, you will need to take 25 centimetres cubed of your alkali solution. We do this using a pipette because pipettes are accurate at taking fixed volumes. We then add that to a conical flask. Next we will take our burette. We need to rinse the burette and then fill it with acid. When we fill it with acid, we ensure that we run some through the bottom so that we fill the jet space at the bottom, and we record the burette reading from the bottom of the meniscus. Then we will take a few drops of indicator solution and add it to our alkali. In our case, we are going to use phenolphthalein. This is pink in alkali and turns colourless once it becomes neutral. We then place the conical flask on top of a white tile to enable us to see the colour change better, and we place it underneath the burette with the acid in. We will then start to add the acid from the burette, and the first time we do this, we can do this relatively quickly and get a rough idea of what volume of acid it took to change the solution from pink to colourless. We then refill the burette and the conical flask with fresh solution, and we continue to do the titration again, this time going quite fast initially, but as we get closer to the value that we got for our rough titration, then we will start to add the acid more slowly. When we get to this point, we will add the acid drop by drop, swirling after every drop so that we get an accurate measurement of exactly how much acid it takes to neutralise the alkali. We then ensure that we write down this value in our results table. Okay, so here I have the 6 main steps that are required to carry out a titration. I would like you to take the 6 steps and see if you can put them into the correct order. I'm going to give you 5 minutes to do this. How did you get on then? So first of all, we're going to use a graduated pipette to measure out a fixed volume of alkali solution and use that to transfer it to a conical flask. Usually we use 25 centimetres cubed. We're then going to fill our burette with dilute acid of a known concentration, making sure the bottom of the meniscus is on 0 and that it's flushed through so there's no air bubbles. We are then going to add a few drops of indicator to the flask and put the flask on a white tile under the burette. If we use phenolphthalein, at this point the indicator will be pink. We then do a first titration, which is a rough trial to give you an idea of the end point. We are then going to repeat the procedure, but this time when we near the end point we are going to add acid drop by drop and swirl the flask until the end point is reached, which is when the alkali is just neutralised and the indicator changes colour. We then need to make sure that we record the volume of acid that was added from the burette. Did you get them all right? If not, pause the video and make any corrections you need to make. Okay, so let's have a look at this exam question. It asks you to describe a method to find the exact volume of sodium hydroxide that reacts with 25 centimetres cubed of hydrochloric acid. It's a 6-mark question, so if we use bug, we box our command words, we can see that it's a describe question, so we're going to need to give a step-by-step method. We must ensure that we include a risk assessment and not forget to write down any measurements that you will take. We underline the keywords, it talks about the exact volume, and it also talks about 25 centimetres cubed. Okay, I'm going to give you 5 minutes to have a go at writing that method. Okay, so that ends our lesson on titrations today. If you would like to make some additional notes, then summary follows on the next few slides. Just pause the video and make any notes that you may wish to.